Tonight, a simple trick for finding new words we can't see. Look at a star. Now imagine a small planet passing in front of it, just for a moment, from a point of view. As the planet transits the star, a tiny bit of starlight is blocked. From far away, the star appears to dim slightly, then return to normal. That little dip is a clue. We don't need a close-up picture of the planet. We just watch the star's brightness over time. On a simple chart, brightness runs flat, then a neat U-shaped dip, then flat again. If the same dip repeats at regular intervals, we may have found a planet. What can that dip tell us? First, size. Bigger planet, deeper dip. A giant like Jupiter hides more of the star's surface than a small rocky world, so the brightness falls a touch more during transit. Second, orbit. The time between dips is the planet's period, how long it takes to go around the star. Short period, the planet is closer in. Long period, it's farther away. The duration of the dip also helps. A longer crossing usually means a slower path or a bigger star. Third, sometimes the shape of the dip whispers extra details. A very crisp U can hint at a clean passage. A slightly rounded bottom can hint at an atmosphere blurring the edge, a teaser for more advanced work. Why does this method work so well? Because we can monitor many stars at once. Telescopes like Kepler and TAS simply stare and measure tiny changes in light, night after night. Out of those patient measurements come thousands of candidates, many of them worlds we never expected. There are limits. The geometry has to be lucky. The planet's orbit must be lined up so it crosses the star from our viewpoint. Many real planets won't transit at all, so we only see a slice of what's out there. And dips can be mimicked by star spots, by two stars eclipsing each other, or by instrument noise. That's why scientists look for repeatable patterns and follow up with other methods, like radial velocity, which measures a tiny wobble in a star. Best of all, transits let us study atmospheres. During a transit, a thin ring of starlight filters through the planet's air. Different gases leave faint fingerprints in that light. With careful instruments, we can ask not just, is there a planet, but what is its sky made of? Takeaway: by watching for a small regular teaming, we can find planets across impossible distances and begin to sketch their size, and even a hint of their air, all from a gentle dip in starlight. Sleep well.